Morning, good afternoon, and good evening, ladies and gentlemen. This is Vincent Tan speaking. This time, I'm going to talk about the refrigerant cycles, which is how the refrigerant flows inside this condensing unit. And this chapter is for Unit 16, the Economic series. Meanwhile, I also provide the corrected subtitle just for your better understanding, so don't forget to turn it on. This is slide. Let's analyze the cooling cycle first. And this one is the side system cycles physical. And here is the pH diagram just for your better understanding. And inside this physical diagram, we have the out dot unit, this part, and the in dot unit. And they just connect with 24-volt thermostat. Total accept any brand of the thermostat, no worries. And focus on the outdoor unit, so you can find that there is a compressor, four-way valve, and the pressure switch. Just in case if there is the pressure exceeds the limit, and also there is a pressure sensor to detect the pressure condenser to release the heat in cooling mode and absorb heat in heating mode. And for the metering device, it is the electronic expansion valve. And let's focus on the indoor unit. Actually, this part is the same as the Unix 18, also called A series, which means we require it should have a thermal expansion valve and then the evaporator. So let's focus on the cooling mode and how the refrigerant flow is from the compressor. It is the high pressure and temperature gas, and then it will go through the four-way valve to the condensing unit, to this one, to release the heat. Then the gas will become the liquid, but the pressure no change, right? And the refrigerant not metering at this one here. It just we go to here to do the cooling. So on site, actually, we don't require the insulation at the liquid pipe. So question number one, where is the liquid pipe? It's here, right? And so because here is still benefit to the cooling, we don't require to do the uh, insulation on the liquid pipe if this is only for the cooling. And then the refrigerant will make metering here, which is from the liquid to from high pressure to low pressure, but still liquid. We'll go to here, right? Still liquid. And then after metering, the refrigerant will get into the evaporator to absorb it, which is doing cooling and become a gas. Then flow back to the outdoor unit, then to the gas liquid separator, and after separated, then to the compressor. Next, we go to the heating cycle. The refrigerant from the compressor, this time we go to the indoor side, which is the evaporator first. Then the high pressure and temperature gas will release heat, which is doing heating and become liquid. And then we get through this TEV. And attention, this time here is not the metering device, which is we flow to the outdoor at this EXV to do the metering. Then the liquid will be still remain liquid, but the pressure change from high to low, which is this one. Then it will go to the condenser to absorb heat, then to the gas liquid separator, then to the compressor to finish the cycle. And also you can find that for the Unix, as you cannot get the information between the indoor and outdoor. It just send the signals to this 24-volt thermostat. So the outdoor unit cannot get the information in time, which will lead to a delay to change or to adjust the parameter. For more detail, please go to watch my another refrigerant cycle, and that is on the Unix 18, also called A series, the video. I put the linkage at the below description area just for your reference. Last but not least, for the piping insulation, here is the gas pipe. In cooling mode, it will be very cold, and in heating mode, it's very hot. So we don't would like to sacrifice this capacity, so insulation is required. As for the liquid pipe, just like what I said, in cooling mode, this part, even with this heat, but it is a benefit to the capacity. We don't require it for cooling. And in heating, this part is hot, which is also warmer than the outdoor ambient. So if you don't would like to sacrifice this part, also require to insulate. So in summarize, in the cooling only, this one don't need insulation, but in a heat pump system, here we require the insulation. All for this sharing. If you still have any other question or suggestion, feel free to contact me on my email address. Hasta la próxima. それではまた今度。